Hi class, in this second video here, we're going to move into questions 4, 5, and 6 for your case study. And this one's a little bit harder and a little bit more confusing, so I'm going to try my best to make it have sense for you. So we have this new survey here, and it says, why do you like texting? And it's convenient for basic information, works where talking won't do, quicker than calling, easier when facing arguments, dislike phone conversations, and great for flirting. All right, anyways, in a survey, U.S. adults were asked to give reasons why they like texting. You can see it right there. So we're going to do a hypothesis test on this. Okay, so select one of the categories to use as the basis for the case study for inferential statistics. So I'm going to select quicker than calling. So everyone should select something different here. Okay, quicker than calling. And it says define the population parameter P for the reason and make a claim about this. So mine is I'm going to let P be equal to the proportion of adults who like texting because it's quicker than calling. Right? And my claim here is going to be this. I think this proportion is, so look at this. The survey said it was 56%. So what my claim is going to be is I think the proportion is greater than 56%. Okay? I actually think in the real world it's better, higher than this. Okay? So we're going to work through a hypothesis test to test this. All right, so it says determine the minimum sample size needed for a distribution of sample proportions P hat to be normally distributed. So you're just going to take 10 divided by, then in parentheses, whatever one you select, you're going to change it to a decimal, 0.56 times, and then also in parentheses 1 minus 0.56. And this would be my minimum sample size needed, 83. Okay. So it's really 83.3333, so 84 for the sampling distribution of P hat to be normal. All right, so then it says choose a sample size based on your results. Okay, I'm just going to select 100. I'm just going to round it up. Okay, so selecting n is equal to 100. All right, identify the mean. Well, the mean would be equal to 0.56. It's the only statistics we have. And the standard error would be equal to, so again, just use that formula here, okay? So it's going to be the square root of 0.56 times 1 minus 0.56. And remember, I said a sample size, I was selecting 100. And I'm going to get 0.0496. 0.0496. Okay, got this. Boom. Let's go to question 5. Using the same reason you selected above, create a one-question survey to administer to cell phone users. The survey must be administered to at least n cell phone users. So based on the value of n determined in number 4. Okay, so I honestly have to. They really want you to do a survey of 100 people, but you can fudge it here. That's okay, So the question should be posed like this. Do you like texting because, and then fill in the blank, it is, and then I selected quicker than calling. So imagine that you were going to write a survey to do this and talk about how you would administer the survey, okay? And talk about any bias you might do. So like what I might do is, I might post my survey on Facebook, but the problem is that'll create bias because it's only selecting my friends. So it's a convenient sample, so that has bias. So talk about that, maybe discuss how you would do a better survey. So next it says state the question you presented in the summary stats. So I'm not really going to distribute this to 100 people. So what I'm going to say here is, look, n is equal to 100 people. And it turns out that X, which is the number of people who say they do like it because it's quicker than calling. Let's just say X ended up being 65. Okay. So 65 people said they like texting because it's quicker than calling. Okay. So again, for us, you don't need to administer the survey to 100 people. Just come up with some own results you might think. All right. So here, continuing with the same reason used in numbers 4 and 5, assume the value of the graphic table is the population to be tested. Okay, so state the hypothesis. So my null here is that, remember, my hypothesis, my claim, was I think it's greater than 56%. So it's going to be 0. The null is going to be that my proportion is equal to 0.56. And what I want to test is like, no way, it's greater than 0.56. Select the level of significance. I'm going to do 0.05. So execute the test I'm going to do in StatCrunch. So you'll have to show you results, but I'll just show you in the video here. So I'm going to go to stat, proportion stat, one sample, and it's with summary. So there were 65 people who said they liked it out of 100. And my hypothesis here, I'm going to have to change to be 0.56, and I'm testing my alternative to see if it's greater than based on this. So I'm going to hit compute, and you can see here are my results. Okay, and what I'm really interested in is that p-value at the end there. Okay, so state the decision on the rule, based on the rule that you've learned previously. So look, here we reject the null because the p-value is less than the level of significance. And so interpret the decision. So basically what that's saying is look, evidence suggests that more than 56% of people like texting because it's quicker than calling. All right. So what you're going to have to do is you're going to have to replicate this for your own case study. And as always, I'm here to answer any questions that you have. And it is going to be a little confusing, and hopefully you watch this video multiple times and go back and forth to see how to do this. But I'm always here for you.